All right, so for the types of energy, looking at gravitational potential energy first, that's the energy an object, well, within a system, be more accurate, within a system, if an object is above h, which is the height, equaling 0. So I put height in parentheses here because remember we can move around where our height is. Okay, so gravitational potential energy, energy within a system if an object's height is above 0. State an equation. Hopefully you know that UG equals mg y or mgh. What must an object have or be doing? It has to be higher than h equals 0 or y equals 0. Anything above y equals 0 means the object will have gravitational potential energy. We did that. That's what does it take to increase this type of energy? Go higher. What does it take to decrease this type of energy? Go lower. What system possesses each type of energy? A system of an object, Earth. Remember, if there is no Earth in your system, then there is no gravitational potential energy because there's not a potential to fall back to anything. All right, next up we've got kinetic energy. This is the energy of motion. That's what it says, motion. State an equation, k equals 1/2 mv squared. What must an object have? Well, you got to be moving. It's the energy of motion. What else? What does it take to increase this type of energy? Well, if you have to be moving and you want to increase it, move faster. Of course. What does it take to decrease? Slower. What system possesses this type of energy? Anything with any system with moving objects, either one or multiple. Right, to elastic potential energy. That is spring energy. Well, spring might be limiting because if you're dealing with a rubber band, you have elastic potential energy if that rubber band becomes compressed or extended. So spring is not a great word, but I would say energy that can restore. So an energy that can restore. So if you think about a spring and you compress that spring, you pull that spring back, then there's spring potential energy there because that energy can restore the spring back to its equilibrium point. Or if you stretch that spring. Or if you take a bungee cord and you pull the bungee cord all the way down, there's spring potential energy in that bungee cord, but that potential energy is going to restore it back to its original length. So restore length to make it better. State an equation. We have U sub s, 1/2 kx squared. Remember, k is a spring constant. Does not have to be a spring to have a spring constant. What does an object have to be doing? Spring must be compressed or extended. And what does it take to increase this energy? Stretch or compress? Whether it's a bungee cord, a rubber band. What does it take to decrease this type of energy? return to equilibrium. I'll shorten equilibrium to an EQ. I don't know that if I don't even think anybody's reading this, but I don't know, I'm writing it. What system possesses each type of energy? A system of not springs, but let's say springy things. So anything that's kind of springy. Last up, dissipated energy. I'm going to have to erase all of this. So our dissipated energy is going to be the energy of wiggling molecules. Wiggling molecules. Equation for that, dissipated energy. Dissipated energy for us is mostly going to be heat and sound. So whenever you're following energy transformations during an event, remember that energy is lost through heat and sound. What must an object have or be doing to have this type of energy? An object has to have wiggling molecules, of course. And those wiggling molecules are going to vibrate and collide with each other, and that energy is going to be released as thermal energy. Or those molecules are going to wiggle and vibrate the air, and that is going to be picked up by your ears as sound. And that sound energy is just going to go on forever and ever and ever until those wiggling molecules lose energy through collisions. What does it take to increase the dissipated energy? Those molecules need to move faster. How can this happen? If an object is moving fast and it collides with another object, say a car crash, then you're going to have a release of sound and heat. So if a car is moving twice as fast, you would have even more sound and heat. And that's because these molecules are wiggling faster. To decrease, wiggle less, go slower, little molecules. What system possesses each type of energy? Just the molecules of an object. Molecules of an object. So that's it for this chart. Hopefully you were able to fill it in without me